I'd like to introduce my colleague, Colonel Tomlinson. She'll be our keynote speaker. I'm just the warm-up band. She's the Test Enterprise Division Chief for Space Training and Readiness Command, STARCOM, at Peterson Space Force Base in Colorado. She's also the STARCOM Commander's Deputy Operational Test Authority. In these two roles, she is responsible for establishing STARCOM's test enterprise, managing and executing the continuum of tests for space systems and capabilities. Colonel Tomlinson's background is principally in operational testing, having served 2 assignments in the Air Force Test and Evaluation Center, first as the test director for the Space-Based Infrared Systems GEO-1 test campaign, and later as AFOTEC Detachment 4's deputy commander. She also had 2 assignments with 14th Test Squadron and Air Combat Command, first as the Detachment 4 commander responsible for testing the Eastern and Western Range Launch and Test Range Systems, and later commanding the 14th Test Squadron, which tested major sustainment upgrades for space systems, as well as conducting tactics, development, and evaluations, and the Space Weapon Systems Evaluation Program. Whew. All right, and with that, Colonel Tomlinson.
Great to see so many familiar faces out here. So I know you were expecting Major General Bratton, my commander. Unfortunately, he was not able to come, and so he sent me in his place. I'll try to get this right. He was very excited to come out here to DataWorks, and he had prepared a special speech for you today, and I'm going to present that to you. So my hope is that you will gain from this discussion an understanding of the breadth of STARCOM's responsibilities. We're the new kids on the block here, right? DataWorks has been around longer than STARCOM has. In fact, DataWorks has been around longer than the United States Space Force has. So we're the new kids on the block, and I'm here to ensure you understand the STARCOM's responsibilities for the readiness of the United States Space Force, and you'll gain a perspective on the Space Force test enterprise and supporting infrastructure to inform your own work. I understand, having done this for a while, it can get very easy. It's very easy to get lost in the data and to forget what it's all about. I do want to throw in just a quick point here. I'm going off script. I said STARCOM is Space Training and Readiness Command. There were a lot of us plugging for that T to be test. We tried to do STARTCOM, but that didn't sound quite right. So we're capturing the test under the readiness. So just think of it that way. I will tell you that if you ever have the opportunity to read one of my documents, read it closely. I might very well have said Space Test and Readiness Command. So I am excited to be here at DataWorks myself because I love working with technical professionals like you. There are a lot of people of great caliber that I've had the opportunity to work with in the past that I see out in the crowd and that I saw out in the lobby, and that's just fantastic. I love working with all of you. DataWorks is the bridge between my world of test and evaluation for military space and you, the doers, who can help me with my mission. The technical skill you bring is impressive, and it's of great benefit for me to be out here to hear from you and to learn from you. But before I really get into this, I want to set the stage a bit. So as I'm sure we're all aware, a pretty epic space test took place last week. SpaceX tested its Starship rocket, the biggest and most powerful rocket ever built. The rocket had 33 Raptor engines generating about 16.5 million tons of thrust at liftoff, which is nearly twice as much as the previous record holder, NASA's Space Launch System mega rocket, which flew for the first time last November on the Artemis 1 moon mission, and I'll talk about that briefly a little bit later. The goal of this SpaceX test was to gather data, which of course is the key to our profession. Starship made it about 24 miles up before a booster separation issue occurred. The 165-foot-tall Starship upper stage was supposed to separate from the first stage about 3 minutes after liftoff, but that didn't happen. Instead, what happened was the vehicle experienced multiple engines out during this flight test. It lost altitude and it began to tumble. That should be coming up any second now. The flight termination system was commanded on both the booster and the ship, and the rocket experienced what SpaceX called a rapid unscheduled disassembly. I love it. I'll be honest, I cannot lie. I've worked the space launch mission for about 3 years myself. I'll tell you that we all want a successful launch, right? We go into every launch, we want to see a great launch out there. We want no errors in the countdown, and we want to see the satellites on orbit. I'll tell you honestly, all of us want to see the rocket go boom, too. Yeah. But you saw the mood at SpaceX just a moment ago. For true space test professionals, we appreciate there's a lot to be learned from failure. So I don't think they're cheering because the rocket went boom, although there's probably a little bit of that. The important thing that they understand is they're learning right now. From that event, they are learning, and they're staying positive and ready to keep perfecting the system. So for those of you unfamiliar with the Space Force, we stood up in December 2019 as the 6th branch of the military. We defend and project space power, which means protecting our space systems from threats and employing those systems to deter adversaries. When people generally think about the Space Force, for example, if I ask any of my relatives, probably not you professionals here in the room, they're usually thinking about rocket launches, satellites, and the capabilities that are up there in space. And they're not wrong. But STARCOM is the field command responsible for testing and evaluating these systems and capabilities to ensure that they're ready for the mission. Not just space operations in a benign environment, such as providing GPS that got a lot of us here today, but also weapon systems, ready to protect and defend space power and deter adversaries. But the Space Force is more than just systems, it's also the people. The guardians who develop and test and operate these capabilities, delivering space power to the nation. Space Training and Readiness Command is really at the intersection of systems and people. Training and education, talent development, fielding of new systems through test, development of doctrine to build our force, and wargaming to develop operational concepts. This is a tremendous challenge for STARCOM, and we're ready to meet it. Because there are incredible space capabilities out there for all countries to use, but we believe the advantage the Space Force brings is the advantage that maximizes our competitive edge is our people, our guardians. STARCOM's role in the Space Force is to maximize the advantage that the guardians give us and to pair it with the systems we all think about when we think of the Space Force. I'll give you some insight into how we do that and also give you an exciting opportunity to get involved with our mission of maximizing the guardian advantage. First, revisiting that concept that guardians are our single biggest advantage we have in the Space Force. Our Chief of Space Operations, General Saltzman, he recognizes this. He's said many times that even our most capable and resilient space systems will be operationally ineffective if our personnel and our expertise are lacking. So I think General Saltzman is right on the money. The skill and will of our guardians is the biggest advantage. In fact, they're our competitive edge. When we look at our challengers in the space domain, it becomes clear that people are what set apart the Space Force. The PLA might have advanced space launch systems and satellites, but when we just look at these headlines from the news here, we can see that they have a people problem. They've referred to themselves as equipment awaiting talent. They lack the right education, and they lack the right training, specifically joint training. Honestly, the same goes for Russia. If you take a look at what's going on in the Ukraine, what you've got on paper is a very capable Russian military, but they don't necessarily have the training, they don't necessarily have the operational concepts for multi-domain operations. When you contrast that with the Space Force, where we have an entire field command, Space Training and Readiness Command, dedicated to training and educating guardians, to understand what makes guardians unique and gives us a competitive advantage, let's take a moment to look at our history. As we started out early in the space domain, there were difficult problems we've never faced before, and we needed to find solutions. And the engineers were there for us to solve them. Their formal training came from academia, from universities. We gave them our problems, and they creatively solved them for us. And that was a bit of what, well, I sometimes call cowboy ops. It's undisciplined. Engineers dominated early space operations, and they were brilliant, but they lacked operational discipline and insight into ongoing military operations and joint warfighting needs. So as we normalized operations in the space domain, we brought in the operators, and they added operational rigor and checklist discipline instead of the cowboy ops where everything was new all the time. But we didn't stop developing space capabilities. We still needed engineers. There were still new problems to solve. And so really we added operations to engineering. Around the time I came into the Space Force in 1993, actually I came into the Air Force, sorry about that. The time I enlisted in the Air Force myself, we started to integrate space capabilities with the Department of Defense. We integrated air, land, and sea capabilities, bringing space into that last tactical mile. Absent a peer threat or a peer adversary in the 1990s, the integrators had little incentive to pursue space superiority, and every incentive to continue integrating space into the other warfighting domains. As the integrators did this, space became an adjunct to warfighting, and Air Force Space Command became a service provider. But we didn't stop doing operations. We're still flying spacecraft, we're still doing engineering, and we added another layer of complexity onto our operations. Then 2007, China demonstrated that direct ascent ASAT capability that changed how we think about the space domain. They allowed us to start calling it a contested environment. We moved from a benign domain to a warfighting domain. We acknowledged offensive and defensive space capabilities. Culture shifted from missions like provide, enable, enhance, to mission descriptors like to protect, to deter, and to defeat. We're focused now on space superiority, on the adversary, on the threats they bring, threats increasingly more sophisticated like ASATs, lasers, cyber attacks, and other electromagnetic spectrum attacks. Guardians are the ultimate realization of the warfighter mindset for space professionals. And the stand-up of the Space Force in 2019 made this warfighter mindset official. Guardians evolved and elevated the warfighting spirit while still retaining the spirit of the engineers, operators, and integrators. Guardians need specialized education, doctrine, and also test and evaluation, and that's where STARCOM comes in. I love that picture there. This is STARCOM. This is our patches up there. You'll find all of the STARCOM units have the blue outline. If you're working with our friends in the acquisition community as you're going about your work, they're in Systems Command, you'll find that they have a bright yellow outline. And then you'll know that you're really doing test right when you look around the room and you see the operators from Space Operations Command with the platinum outline around their patches. They're not quite as sharp as our bright blue patches, but they're good enough. So STARCOM is focused on the readiness of the Space Force. It's right there in the name. We train and educate Guardians. We give them doctrine. We also support the technical side of things with test and evaluation and provide the range infrastructure to test and train in. All of these things come together to maximize that Guardian advantage of our people. We're going to start with training. Here you see our newest Guardians training to enter the force. The basic training they're receiving is very different from the basic training I went through, what the engineers, operators, and integrators from past eras received. We completely revamped basic training and tailored it to the warfighters. This means we have Guardian instructors teaching new Space Force curriculum to all Guardian flights. From day one, we instruct Guardians to think in terms of a contested domain. And we take them all the way through advanced training in warfighting concepts. We have highly realistic training exercises like Space Flag and Black Skies, where we challenge our Guardians to overcome realistic threats in the space domain. This photo right here, this is from Space Flag, a planner's exercise that we use to solve our toughest problems. We recently held the largest Space Flag ever. We've been doing it for a while, since before the Space Force existed. But we held the largest Space Flag ever with 120 participants from nearly a dozen Space Force deltas, as well as members of the Air Force and the Army. This exercise was also notable for being the first ever joint accredited Space Flag. We're adding an exercise series called Skies, where we do less simulating and planning and more live combat training. And we've held 2 Black Skies events. You'll hear a little bit more about them later. Generally, they are geared toward electronic warfare Guardians. And we have Red Skies coming up for the orbital warfare Guardians, and then the Blue Skies for cyber Guardians. In addition to training, the second way STARCOM maximizes Guardian advantage is through education. You can think of training as preparing Guardians for the known, while education is preparing Guardians for the unknown. We teach Guardians how to partner with allies, how to understand adversary threats, how to navigate the policy and the legal aspects of the space domain. The Space Force is all about changing things up, doing what we need to do, doing it differently in support of our Guardians and our mission. We've partnered with Johns Hopkins University to be the home of intermediate and senior officer education. And this one is huge for us in this community. We've coordinated with the Air Force Test Pilot School to finally establish a space test course. We have previously sent Guardians, or in the old days, Air Force space operators, through test pilot school for the flight test engineering course, but honestly it just didn't serve the needs of the Space Force and space operations. So now we have a space test course. I was just out there last week for the board to select candidates for the 2024 classes, and I got to spend some time on the rocket test range with the current class. I got that picture there myself. I know it's not the greatest, I'm not a PA professional, but I thought it was pretty cool. I got to watch them launch. The current class will launch their telemetered rockets to gather data to validate the models that they had built during their courseware. So this current class is only 5 months long, and we'll have a second 5-month class later this year. The class I was selecting the candidates for is going to be a 7-month class. And then after they graduate, they're going to stick around out there. This is at Edwards Air Force Base. They're going to stick around out there for another 5 months to continue developing the curriculum. They're going to have some special test projects, and the material that they develop during their special capstone test projects is going to go into a future course. Our intention is by 2026, we should have an accredited course offering a Master's of Science in Test Engineering. Now, test engineering is notional at this time. We're still working on the exact title. If you go through test pilot school, you get a Master's in Flight Test Engineering. We're trying to drop that flight off there. And of course, this aligns very well with DOT&E's pillar of developing the workforce. Beyond training and education, STARCOM is also responsible for doctrine. So normally, you develop doctrine from experience in warfighting, and you gather the lessons learned, figure out what worked, were successful, and you put them into your services doctrine. Well, we have never fought a war in space, and we really don't want to. But we do have to be ready. We have to have a warfighting doctrine so that we can use it to inform our training, inform our education. Also, specific to our environment here, we need that doctrine to inform how we're going to set up realistic test and evaluation, right? So we need that doctrine so we can ensure that we maximize our advantages. What we normally do right now, we approach doctrine by having a bunch of smart people, shown here on the screen, coming up with great ideas. And we run them through a campaign of learning and a series of war games. This is just the brainstorming part. This is not the war games. Right there, you have the team from the Schriever War Games that just concluded a couple of weeks ago. 8 nations, members from INDOPACOM, US Spacecom, our civil partners, including NASA, Department of Commerce, Department of State, other services and partners, and 10 companies. They were there with us at this Schriever War Game, going through this campaign of learning to determine what's going to survive and get written into doctrine. So far, we've talked about maximizing Guardian advantage through training, education, and doctrine. This is the people side of the equation. So now we get into the business that we're all here for at DataWorks. Let's take a look at our test and evaluation mission set, which is what gets systems into the hands of the Guardians. STARCOM's test portfolio includes about 87 programs, and it's growing, seemingly daily. I get calls from different agencies who have a new program in need of testing. And honestly, this is a growth area for STARCOM. We are about at capacity, but we don't want to say no to any test ever, honestly, because, well, first of all, we love doing tests, but also we recognize the significant importance of test to delivering the space capabilities. So this space capabilities chart right here, this is just a fraction of STARCOM's portfolio. There's a lot that we didn't put on there. And our test portfolio covers the entire spectrum of test, from prototypes and demonstrations, pre-program of record to formal program of record. We're involved in the oversight of contractor testing, and of course, we're responsible for the formal government developmental, integrated, and operational testing. After systems are fielded, I don't take them out of the portfolio. They stay in our test portfolio for tactics development and evaluation, and also our weapon system evaluation program. STARCOM partners with agencies to field new systems, and these agencies include things not only our Space Systems Command within the Space Force, but also the Air Force Research Laboratories, DARPA, the Space Rapid Capabilities Office, the Air Force Rapid Capabilities Office, the Space Development Agency, all sorts of new agencies to field new systems, test them, understand their capabilities, the operational concepts, to develop the tactics, techniques, and procedures to understand what training we need, and all of this in support of a fully burdened system that STARCOM helps to deliver to operations. So I said that STARCOM, the test enterprise, is probably the greatest area of growth for our command. We're standing up new test organizations to be able to wring out the best of our capabilities, but more importantly, to be able to combine it with that human element and those guardians to maximize the advantage of both the personnel and systems that we bring to bear. So I offer up here this quad chart, this quadrant chart for perspective or to help frame the discussion. On the vertical axis, you see missions, like we showed on the last slide right there, and we've labeled them new and legacy. And then on the y-axis, or the horizontal axis, you see the capabilities or the specific systems we saw on the last slide. And again, we've bucketed them into new and legacy. So from legacy systems performing legacy missions, to getting creative and seeing if a legacy system can conduct a new mission, to testing new systems for completely new missions, STARCOM is responsible for it all. So we're going to start out with SBIRS, the Space-Based Infrared System. You heard from the Honorable Gerton that was my first ever test mission. So I didn't even choose this slide. This is the General's presentation here, and I was pretty excited to see that he had SBIRS GEO-6 up here. It's very near and dear to my heart. When I joined the Air Force Operational Test and Evaluation Center, I knew nothing about tests. I didn't know that there was a center specific for it. And I was originally assigned to the Enhanced Polar Satellite. And that system is a communications satellite. I had never in my career done anything related to communications, so AFOTEC sent me off to the National Space Securities Institute for an advanced ComSat training course. I did so well in the course that when I returned back to AFOTEC, they promptly assigned me to SBIRS GEO. I had a little bit of missile warning experience. I didn't get to go to the class to flesh out that experience, but nevertheless, I learned a lot from this program. It was a great opportunity. And I learned to love also this test and evaluation mission. So if you're not familiar with it, the SBIRS constellation provides missile warning capabilities by detecting rocket and missile launches, detects missile impacts. If we have something exciting like the SpaceX rocket, it's going to detect those space launch impacts. We try to minimize those. Also nuclear detonations, basically anything very hot on Earth. STARCOM's 17th Test and Evaluation Squadron wrapped up testing on SBIRS GEO-6, the final test in the campaign of a new satellite performing a legacy mission. My SBIRS GEO-1 campaign was 6 months of execution only, not including all of the planning and analysis. SBIRS GEO-6, from start to finish, was about 38 days because the system was very well understood. So this test was principally an on-orbit checkout to ensure the payload and space vehicle are in good working order. So SBIRS is on-orbit missile warning. Next, we're going to look at the upgraded early warning system. These radars are ground-based missile warning, complement to SBIRS. You can see where it lives on that capabilities chart that I showed earlier. It's highlighted there in yellow. This particular radar is at Cape Cod Space Force Station, and it's a good example of a legacy system performing a legacy mission. I love this video because the gentleman standing up there, if you could see his patch closely, you could see he's from the 17th Test Squadron testing new software. The software provides radars with capability to detect more objects and detect them with more precision. And this is pretty dear to my heart because I commanded the 17th through many UEWR test campaigns myself. Now this next slide, so this one took me by surprise. I've never seen this one before. It is the infrastructure of trusted satellite autonomy and tactical rapid anomaly protection. That's quite a lot. It's a trap. So, It's a Trap is a seedling that the Air Force Research Laboratory is running, and we're happy to be part of it. You won't find this on the capabilities chart. It is a new system and conducting a new mission. Artificial intelligence is a pretty hot topic. You heard Honorable Gerton mention it a few minutes ago. Over the last couple of months, you've seen platforms like ChatGPT making their way into the mainstream. And you're probably more technically savvy than I am. I will tell you, I've been surprised at how powerful these AI systems can be. And I'll tell you also, there's not a lot of trust at the operational level in AI systems. We have a lot of concerns about how these operate and whether we're really getting what we normally put an operator in the loop for. Nevertheless, we understand that their power is something that we need to harness. So Air Force Research Laboratory is exploring whether automation technology can help Guardians. A big component of space operations is what we call the cognitive dimension. In our space power, core space power document, we recognize 3 dimensions: physical, network, and cognitive. And the cognitive is the ability to rapidly collect and analyze huge amounts of data, to harness the relevant information and make split-second decisions. Any tool that gives Guardians an edge in the cognitive dimension will be a game changer. To that end, AFRL is developing a reinforcement learning-based neural network to do just that: help Guardians quickly spot anomalies in systems and identify courses of action. AFRL is focused on developing the AI so space operators can trust it. It's a Trap aims to create flexible human autonomy interfaces that accept Guardian-based mission preferences and provide course of action visualization, comparison, and selection mechanisms. STARCOM gets to be part of this exciting test and evaluation, and in the future we'll consider what additional tests that we might want to run on this test bed. Right now we're just partnered with AFRL and taking the lead from them as we work with them on it. The last example I offer you is GEODS. So this is the ground-based electro-optical deep space surveillance system. You can see it highlighted at the bottom of the space capabilities chart. You can't tell from the picture, but if you're not familiar with GEODS, it's a big telescope. This is a legacy system that's been around since the 1980s. But we never believed that you can't teach an old dog new tricks. So in November, when NASA's Artemis launched, we used it as a cooperative target to push GEODS to its limits to see if it can perform a mission that it wasn't designed for. We tested to see if GEODS could collect on objects beyond its maximum design range, because in all likelihood, cislunar missions will be coming for the Space Force. They'll be here before you know it, and just like SpaceX is preparing for. One more time. There we go. All right. So that was an overview of STARCOM's test portfolio. I told you 87 programs. That was just a brief look into what we're doing. So far, I've talked about STARCOM's roles in maximizing the advantage our people provide, and we've spent some time exploring our test and evaluation missions. But there's one area that we haven't really touched on, and this is where the technical challenges live. Everything comes together in the National Space Test and Training Complex. That's not as cool an acronym as the It's a Trap, but I'm still going to use the brief form NISTIC. So when I say NISTIC, this is what I'm talking about. Other services are able to carve out a piece of real estate in the desert, in the sea, or in the sky, but there's no sovereignty in space, or very little. Space operations presents, therefore, some real challenges to the traditional concepts of ranges. We're still in the early stages of planning the NISTIC, but I'm going to give you a rough blueprint of what we're thinking. We have to be able to operate safely and professionally in the same space where our allies, our military, civil, commercial space assets operate, and also where our adversaries operate. So range control is really key, and you see it at the top there. It's key to professional, responsible, safe on-orbit behavior. The NISTIC-O is for the orbital range, where we do our orbital warfare testing and training. NISTIC-E is for the electromagnetic warfare or electromagnetic spectrum operations, testing and training. And then we have the NISTIC-C there for cyber warfare. I should explain that these are not discrete ranges. So it can be a little challenging sometimes to look at these NISTIC-O, E, C, also NISTIC-D, and think of them as separate things, but they're really not. We call it a complex for a reason. These are really just lines of effort to help us communicate, acquire, and operate the NISTIC. So when you think of NISTIC-O, for example, you need to understand it includes not only on-orbit assets and sensors, but also ground-based assets and sensors. We need to be able to observe test activities, receive continuous telemetry, gather and analyze the data. That's not all on orbit, even though it supports orbital warfare. The NISTIC-E for electronic warfare is our most mature capability, but it becomes more and more complex. And the challenges that we face in both offense and defense in this area are significant. So we have the NISTIC-E to better prepare the force to maximize the advantage those units bring us. NISTIC-C is our least mature line of effort. We owe the cyber defenders a place to train, and testers need an environment for adversarial assessments that don't put operational assets at risk. So I'll tell you, we do a lot of our testing in space on real-world systems. And when I go to the GPS commander, and I've done this, and said, hey, sir, we're going to run an adversarial cyber assessment on your live GPS system. He's not very excited about that. It took a lot of convincing to persuade him that we were not going to take down the GPS capabilities. So what we need is the NISTIC cyber to provide an environment where we can have red cyber aggressors attacking and have our blue cyber aggressors defending. And then we can really wring out the cyber capabilities of our systems. And we're just not there yet, but we are working on it. The thing that connects all of this together is the NISTIC D, down there at the bottom. This is the backbone architecture where we're managing data, and we're linking all of these systems together. The NISTIC D is the digital model of the space environment, where models of our blue systems can face off against models of red systems, so we can test out our capabilities in an area that's not too expensive or difficult or challenging to test in the real world, where we can determine capabilities and limitations without revealing them to adversaries, and the cost of failure isn't high. In fact, it can be so cheap to work in the digital environment that we can just reset and try again and continue with our test and evaluation to fully understand the systems. This is a challenge that STARCOM is facing, whether in test and training, and I'll give you a couple concrete things that we've already done right now. So this is Tetra. Recently, in partnership with Space Systems Command, we operated the Tetra-1 spacecraft above GEO, learning how to do range control on orbit. This was a training event for operators, but also a training event for our NISTIC D range control officers there. Last summer, we had our first live data collection with our Harrier telescope suite and the associated data fusion engine. This is our minimal viable product for the NISTIC D. Harrier is a software-defined telescope in which many telescopes can operate independently or they can operate as one. It provides enhanced mission flexibility and sensitivity to discover, track, and characterize dim and closely spaced objects, and allows the NISTIC to train and test for complex operations like dedicated tracking for high-interest objects, high-value asset clearing, lost object recovery, and rendezvous and proximity ops. So when we take a look at the electromagnetic warfare, there we go. All right. Again, that's an area where we're much more mature. So that's representative of the Space Test and Training Complex that used to exist before STARCOM came online. They've run a couple of Black Skies exercises and electromagnetic spectrum warfare test activities. We've had 2 iterations so far, and all of this is just a hint of what we're planning the NISTIC to be, a live, virtual, and constructive test and training complex. So we need your creative ideas to help us build out this NISTIC for Guardians. We need you to come out and help build that infrastructure. So we're hosting an industry day in Colorado Springs, 22 June 2023. We'll have a 60-day announcement coming out very soon. It contains the registration details. The announcement will post on sam.gov over the next couple of days. And also keep an eye out for a request for information that we'll be sending out in tandem with the 60-day announcement. So I started out by saying that I wanted you to understand the breadth of STARCOM's mission, our responsibility to ensure the readiness of the Space Force. You are the experts supporting key aspects of our mission so that we can maximize the Guardian advantage. DataWorks is the opportunity for you to hone your craft and to help us hone ours. So thank you very much for your time and attention today. It's been a real pleasure talking to you, and I look forward to meeting some of you out there in the lobby later on today. Thank you very much.